So, is this
4 over x plus 5 over y, 1 over x minus 4 over y.
yeah.
As a matter of vocabulary,
Yeah.
rational expression, the the key root, so your first GRE lesson is ratio.
Okay.
So basically, you want to write this as a fraction.
Okay.
And right now, there are fractions inside of fractions.
Yeah.
And then furthermore, they're saying in simplified form, x squared times y over x squared times y over x, they want you to simplify and say, well, that's really x times y, because the x squared and the x.
Okay.
That's the word rational expression and the word simplified. Translated, that says write as a fraction where you cancel everything out.
Okay.
All right. Go back to the very beginning. What do you do to add fractions?
Find a common denominator.
And so, if this was like 4 over 7 plus 5 over 8, you'd multiply 7 times 8.
Yeah. So it's xy would be the common denominator, right?
Y over y and x over x.
Okay.
Right?
So that's what you multiply it by, right?
Down here, I'm going to do the same thing.
Okay.
Okay? So let's do this. Is that all the way on the screen? Yeah. So we got 4y over, I'm going to write both as xy, plus 5x over xy.
Yeah.
Divided by y over xy minus 4x over xy. Okay. That becomes 4y plus 5x over xy.
Wait 1 second. Where was the 4y? Oh, so you're adding the top. Okay. I'm sorry. I had a momentary lapse.
Like calculus lecture mode. Like this is how it would show up on the board, and
Yeah.
maybe I should. And I'm on here. I'm gonna go back to, we had 4y over xy. 5x over xy, and then down here we've got y over xy minus 4x over xy, right?
Yeah.
Okay. Now you're just, you add the numerators.
Okay. Yeah.
Right.
Yeah.
So we're gonna get 4y plus 5x over xy divided by y minus 4x over xy. Now, from the way you described your previous life in math, I'm guessing that once you have all these recipes in your pocket, you're not going to mess up the algebra.
Yeah, no.
Right? Okay. But anyway, again, what we have here is we're dividing fractions. Right? So what did you do in 6th grade when you did 3/4 divided by 1/2? Is you flip the one on the bottom upside down.
Yeah. The inverse. Okay. Yeah.
Same thing here. So we're going to take the one on the bottom and flip it upside down.
Yeah, so we're going to...
over xy times xy over y minus 4x.
Okay.
Okay, now that kind of thing happens.
Yeah.
Is that something that you
Yeah,
were?
I get that.
And then we're down to, um, well, that's it. 4y. Well, usually you write things in alphabetical order, so you'd write it as 5x plus 4y. Oh,
Fine.
well, minus 4x plus y. I don't know.
Yeah. So that there, that's simplified.
Yeah, there's nothing to cancel now.
Yeah.
Could have been a little trickier, and they could have given you something like, how about, let's say, two, let's do 8, if I have something like 8x
Yeah.
divided by y minus 4x,
Yeah.
now this expression is actually equal to negative 2.
Yeah.
Um,
Like you can cancel out one or divide out one of the y's, correct?
uh,
And then,
don't
yeah, that.
don't start doing things like, oh, these cancel.
No, it's minus one, right? Because it's dividing.
Be careful. I don't know. Maybe what you're saying is right.
Okay.
I don't want to I don't want to lead you
No,
astray.
go ahead.
One thing you can do is factor out a 4, not a 4, but a 2 from the numerator.
Okay.
That's like straightforward. Now you have 4x minus y. So factoring out a 2 just comes from the fact that we always look at the numbers and
To
do.
see if there's, yeah.
Now down here I got y minus 4x. Okay, a quirk of numbers is that a minus b over b minus a is negative 1.
Okay.
And we can think about that. Maybe an obvious way to do it is instead of factoring a, so I want to erase that because I don't want you to like copy over that you can cancel out the y.
Yeah.
Instead
Okay.
of 2, let's factor out a negative 2.
Okay.
And now we got plus y, which is the same
Uh,
as minus 4.
uh,
Okay?
yeah.
Um, this is, so now we're on to something that actually comes up,
Okay.
and that is, there's a very specific problem that I'm thinking of where you kind of have to know this trick, otherwise you won't do it. And how could you know to factor out a negative 2 instead of a 2? If you go back to the original setup, we had 8x minus 2y in my invented problem.
Okay.
Y minus 4x.
Yeah.
You can always set yourself a goal of like, okay, I want to make the coefficient of y be the same.
Okay.
If this coefficient is 1,
Uh-huh.
this coefficient 1, while I factor out a negative.
Okay.
That's a way that you can like think of it for yourself.
Uh-huh. To make sure you get the right sign.
Say like, how would I ever think of that? There's no there's no rule book for factoring, but you can go by these rules of thumb where like, let's just do our best to make the top as close as we can to the bottom. And one way to do that is say, well, let's make these coefficients the same.
Okay.
Example, if this was 3x, or sorry, if this was 6x minus 2y over y minus 4x, the same method, if you want to call it that, would get
Yeah.
you minus 2 times minus 3x plus y over y minus 4x. Anyway, the point is here, you just can't simplify it. There's nothing.
Okay. Yeah, I get that.
So
Awesome.
to inject useful knowledge whenever.
Yeah. Oh, I like need it, so it's good. Thank you.
Oh wow! So number 5 is another one of those where this is like stuff you actually need to know.
Okay.
Is all stuff in the answers to number 5 sort of like a complete mystery?
A complete mystery?
Do you know what denotation means for all those intervals?
I'm sorry, the internet cut out. What was that?
In number 5, there
Yeah.
is an abundance of vocabulary.
Okay.
Interval, domain, basically interval and domain are the important things that you may or may not know. So those words, do you know what they mean?
I I'm not sure the interval, but I understand domain. I don't know if I can necessarily explain it, but sort of.
in one sentence, the domain is the x's
Okay.
that don't. Okay.
Okay. Yeah.
And
Uh-huh.
you make the rules. You take a square root of a negative number, you divide by 0, or you take the log of 0 or less. So I'm going to write that down.
Okay. Yeah. I'll do that.
So bad are anything over 0. Okay. Square root of a negative. And then the last one, which is, I don't even know, I'd have to look at your syllabus.
Okay.
How important this is for you. But you can't take the natural log of anything that is 0 or a negative.
Okay.
Okay? Another way to phrase all this,
Uh-huh.
I could say that the domain of f of x equals 1 over x is x not equal to 0. The domain of f of x equals square root of x is x greater than or equal to 0. And then the last one,
Okay.
all right, now this is guaranteed to come up again.
Yeah.
The big ones are the big one is really this one, dividing by 0.
Yeah.
That they're about in problem number 5.
Okay.
So I don't know. File this knowledge that's accumulated on the screen right now.
Yeah.
And I promise that when you need it, it will be a time when you don't know what to do at all, and then I don't know how this is going to be useful because the time that you need it, it's not like it'll just come fresh to mind. But anyway, we're dealing with 3x to the 4 over x squared plus 6x minus 16. All right.
So it wouldn't be true if the bottom equation, the equation in the denominator equals 0, correct?
To prevent, yeah.
Yeah, okay.
Forget, outside of all the theory or whatever, the way you do this is you factor the denominator.
Okay.
And do that on two numbers and multiply to give negative 16, and oh wow, so they're being really irritating because or no, it doesn't. Never mind, 8 and 2, obviously.
Yeah. Okay.
X minus 8, sorry, x plus 8, x minus 2. Right?
Yeah.
Okay. So that means anytime the denominator is 0, right? So if x plus 8 times x minus 2 equals 0, that's bad. Now, there's a little thing about algebra, which is anytime you have things multiply to give 0,
Yeah.
the only way that can happen is if one or the other is 0.
Yeah. Okay.
This into x plus 8 is 0.
Yeah.
Or x minus 2 is 0.
Yeah.
X minus 8, and x is 2.
Okay, so those are two that wouldn't work because that would make it 0. So
Now,
x can't be negative 8 or 2.
right. Now let's look at how that's going to actually show up, like on a graph. Well, let's look at the domain first.
Yeah.
We take the whole real line. That is abbreviated like that. And you would also say this is all the numbers from negative infinity to infinity.
Yeah.
And you parentheses like that. Now we are deleting negative 8 and we're deleting 2.
Yep.
So what we have left is
Infinity. This. Yeah.
Okay.
Yeah.
So these are the 3 pieces that we're looking for. Okay. Now, how does that translate?
Yeah.
What? Write this down using their notation.
Notation, yeah. So would you need the parentheses, the open ones?
The brackets includes the endpoint. So this bit right here, this middle thing, negative 8, comma 2.
Yeah.
Okay. This part would be written parentheses 2, comma infinity.
Yeah.
And this part over here would be negative infinity, comma negative 8.
Yeah.
Right. So now put it all together. U means union, which means I'm taking minus infinity, comma minus 8. I'm putting it together with minus 8, comma 2,
yep.
And then finally I'm putting it together with 2, comma infinity, and then this whole part.
Yeah, and then so we would use like the bracket if it was like a less than or equal to kind of thing, right? If it was included in the as a possibility.
Yeah. So A good example of when you're going to do that is with square root.
Uh-huh.
So, like, what if I just asked you, what's the domain of f of x equals the square root of 4 minus x?
Yeah.
You would say, okay, well, 4 minus x has to be bigger than or equal to 0, right? Because whatever is inside the square root is bigger than or equal to 0, so you get 4 bigger than or equal to x. Which means that we're dealing with this set, where this is 4.
Yeah.
And we're not dealing with over there.
Yeah, because it would make it 0 or less. Yeah.
Negative infinity, comma 4 with a bracket.
Okay. I get it. I vaguely remembered that, but I couldn't fully remember.
If you took AP Calculus, that you use this all year.
Yeah, no, I just remembered, I vaguely remembered what the open and closed bracket was, but the thing was I couldn't remember the rule that led up to that. So, for instance, you can't take the square root of 0 or a negative. That just wasn't something that freshly popped into my mind. So now that makes sense that that's when that would be used.
Careful, you can take the square root of 0.
Oh, you can't take the square root of 0?
Yes, the square root of 0 is 0.
Oh, okay. So it's just you can't take a square root of a negative. So that means it has to be greater than or equal to 0. So that's why you're using the greater than or equal to sign.
Right.
Gotcha.
Stuff like that, the problem with calculus is there's a lot going on.
Yeah, a lot to remember.
And it's really easy to write x is bigger than 0 when you really mean x is bigger than or equal to 0.
Yeah.
Wish I had some clever advice that would just make people not make that mistake.
Yeah.
The best I can offer is try really hard not to do that.
Yeah, no. I just be aware. I get it.
So I'm seeing you scroll down here.
Yeah, no, I was looking at the next one. I remember how to do slope, I think.
Okay, this is again number 6 is a big deal.
Yeah.
You got,
so that uses the equation that's the y equals mx plus b, correct?
That's right, but you really should know some more stuff. So if you have a point, we'll call it x1, y1.
Yep.
And you have a slope, which is m.
Yeah.
Over here, I'll go with a concrete example. Let's say we have a point 2, 3, and then our slope is negative 1/2.
Okay.
How do you make the line? The recipe is called point slope form. Do you remember this?
Yeah.
Do you remember the equation?
I don't.
The one thing about slope is you probably do remember this. The slope is equal to rise over
that.
Right?
Yeah.
So if I have my x1, y1, so we're thinking of these as numbers.
Yeah.
Out here I have any old xy on my line.
Yeah.
Okay. The rise here is the y minus y1.
Yeah.
Right? Do you see that?
Yeah, I get that.
Then the run is going to be x minus x1.
Yep.
becomes m equals y minus y1 over x minus x1.
Yeah.
Okay? Typically, you'll see this not written like that. See it as you'll move this over
Yeah.
to the m, and then you'll get a point slope form. It'll end up looking like this.
Yeah.
Okay? And this is what you commit to memory.
Yep.
So this is point slope form.
Okay.
What you told me originally was slope intercept.
Okay.
And so that was like y equals mx plus b. The way to think about slope intercept is it's point slope form when the point is 0, b.
Oh, yeah, okay.
The point is 0, b.
Yeah, and wherever the line passes through the y-axis, correct, would be b?
Yeah, right, because words y-intercept mean, and also if you plug in 0 for x,
yeah,
get y equals b.
Y equals b, yeah, okay.
So point slope, slope intercept, I mean, that's good enough, but point slope is the important thing, and also just really getting your head around the fact that slope is rise over rho.
Yeah, I got that.
That's important. That's going to come up again.
Yeah,
so
I definitely remember that.
That's like, has he talked about slope or like equations for tangent lines or anything like that?
No, not that I kept up with. I'm not sure. But
so part A, I've given you the recipe. Part B, the word parallel,
yeah,
really same slope.
yeah. Okay, so I got that. So oops, wait, let me see. Find an equation of the line that passes through the point. Okay, so that's fine. We could do that. Parallel, yeah, I get that. That it will be along the same like slope. I
But
get that.
They're not asking you. The B and C are the least straightforward, because to be parallel to the x-axis means you look like this.
You just go straight out from. Yeah.
So this would be thing like, if this number, well, I've drawn the wrong picture because they say it passes through the point 2, -5.
Yeah.
So the picture would be, I go through this point and I look like that.
Yeah.
Right? The slope is 0 because the rise is 0. There's no difference in the y values between any pair of points.
Okay, so would the answer to B be -5, like y equals -5?
Right.
Yeah.
So it's a constant function. For every value of x, the output is.
It's going to be 5.
So C is a little more tricky. If pass through 2, -5, and I'm parallel to the y-axis.
Yeah.
Now look at that, and I can say the equation is x is 2. Right? They're all without any recipe, like without any point slope or anything like that. Hopefully that's like obvious, right?
Yeah.
But The issue is what's the slope, and here the is 0. If I pick
Yeah.
any 2 points and I do rise over run, something over 0.
Okay, yeah. So that's undefined?
Yeah. Yes. It has no slope.
Okay.
There.
I'm just wondering, or so because so for C here, the answer would be y is equal to.
X is 2.
Oh, so x equals 2.
Right, and that kind of doesn't fit any of the recipes that I. So, this is another example of This is a good question to ask before the course because
Yeah.
this kind of thing comes.
It's not asking me for the slope of the line. Okay, so sorry. Yeah, so it's just asking for the equation for what's
Um,
parallel to. Okay, that line on the x-axis. Okay.
so for something like 2x minus 4y equals 3,
Yeah.
now you just need to find the slope.
Yeah.
Since we put it in y equals mx plus b,
Yeah.
read off the m.
Hmm.
You solve for y.
Yeah.
As far as something like solving for y, is that
Yeah, no, I get that. I could do that.
okay? All right.
Um, so, 1 second. So, is parallel.
So what do
Okay.
you planning to go to grad school for?
What was that?
What's your goal? What do you want to study in grad school?
I'm gonna do pharmacy.
Okay. That's interesting. You have to know math for the PCAT.
Yeah.
I've tutored people in the math for the PCAT.
Yeah.
There's like calculus on there. Anyway.
I know, insane. So actually, let me just work through this right here, and let's see. Let's make sure I get the right answer.
D.
To D, yeah.
Okay, that'll give me a chance to take a break. I'll be back.
Okay.
1 minute. done?
Yeah, actually, so with the